What if I told you your favorite Brita or PUR pitcher might actually be useless? Most people know that tap water can contain all kinds of nasty stuff, from lead and arsenic to emerging contaminants like forever chemicals and microplastics. But can these popular pitchers really remove everything bad from your water? We put the upgraded Brita Elite and PUR Plus filters to the test using a certified lab to find out. Before testing, we purchased each filter brand new and filtered just over 4 gallons of water through them. Our partner Simple Lab provided us with the TapScore test kits we used to analyze our water samples. And for accurate results, we filled a large bucket with our tap water and mixed it thoroughly. The goal here was to ensure a representative sample by homogenizing contaminant levels in the water. We then collected the pre-filtration samples from the mixed bucket, used the same water to filter through the Brita Elite and PUR Plus pitchers, and then collected the post-filtration samples from the pitchers themselves. When we got the lab reports back, our testing revealed some really interesting results. First, let's talk about the quality of our unfiltered tap water. We'll use Simple Labs Health Guideline Levels, or HGLs, as a benchmark to look at the data. These HGLs are much stricter than the EPA's federal regulations and prioritize potential health risks. Now here's where things get concerning. Our unfiltered tap water contained 1.1 parts per million of fluoride and 0.014 parts per million of uranium, both exceeding their respective HGLs. Elevated fluoride intake can damage bones and potentially cause neurological issues in some people, and uranium intake can damage the kidneys. Now let's see how the Brita Elite and PUR Plus filters performed against these contaminants. It's important to understand that neither of these pitchers are certified nor specifically tested to reduce fluoride or uranium, and the manufacturers don't make claims they can do so. So in our case, it turned out that these filters were not the right solution for our specific water situation. The Brita Elite only managed a 26% reduction in uranium, while the PUR Plus fared a little bit better with an 80% reduction. However, neither filter reduced any fluoride. This highlights the importance of testing your water before choosing any filter. Without testing, we might have unknowingly relied on these pitchers for protection they simply couldn't provide. And this is a great example of why water filtration at home can be so tricky. As you might have guessed from our test results, water quality can vary dramatically throughout the country and even within the same region. And it really depends heavily on your area's geography and geology. Our test used tap water from a shared, treated well water source. Wells like this pull water from underground aquifers, which can naturally contain elevated levels of certain contaminants like fluoride and uranium, depending on the local rock formations. Now, this might be different for someone in a city that gets their water from a treatment plant that uses surface water sources like reservoirs, lakes, or rivers. These surface water sources are more susceptible to contamination from agricultural runoff or industrial pollutants. The specific types of contaminants you might encounter completely depend on your specific water source, and in our case, we encountered high levels of fluoride and uranium. However, other areas might have issues with lead, arsenic, disinfection byproducts, or even emerging contaminants like PFAS, also known as forever chemicals. Just like different tools are needed for different jobs, various water treatment technologies target specific contaminants. For example, activated carbon filters are excellent for removing chlorine and some organic compounds, while reverse osmosis systems are highly effective against a wider range of contaminants, including metals and inorganics. The Brita and PUR pitchers we tested likely primarily use a form of activated carbon media. While this explains their inability to address fluoride and uranium, our testing revealed some intriguing results about the other contaminants detected below the HGLs. As expected, both the Brita Elite and PUR Plus effectively removed the residual 1 part per million of chlorine from our tap water. This is because both filters are certified to reduce chlorine, which is a common disinfectant used in municipal water treatment. But the filters performed a bit differently with other detected substances. Brita eliminated phosphorus and barium entirely, while PUR only managed a 4% reduction in barium and actually saw a surprising 20% increase in phosphorus levels after filtration. Both filters were effective at reducing copper. Brita achieved a 97% reduction, while PUR one-upped it with 98%. PUR completely removed strontium, while Brita offered only a 13% reduction. And for molybdenum and nitrate, Brita also fared a bit worse than PUR. Brita provided a minimal 7% reduction in molybdenum, while PUR provided a 23% decrease. Similarly, Brita only achieved a 5% reduction in nitrate, whereas PUR showed a 42% decrease. And interestingly, we saw an impact on healthy minerals like calcium and magnesium that I honestly was not expecting. The PUR Plus filter significantly reduced these minerals with a 96% decrease in calcium and a 94% decrease in magnesium. This indicates the PUR filter likely uses a cation exchange resin to reduce certain ions with a positive charge like barium, lead, and copper, but it also removes these beneficial minerals in the process. Brita, on the other hand, had a minimal impact on calcium levels, only a 2% reduction, but showed a slight increase in magnesium by 2% and sodium by 10%. A 388% increase in sodium with the PUR filter further supports the possibility of a sodium-loaded ion exchange resin being used. 1.66 parts per million of potassium was additionally detected in the PUR's filtered water, where it was absent in the pre-filtration test. So even though popular pitchers like Brita and PUR are convenient, they might not necessarily be the best solution for everyone, especially depending on your location and specific water quality concerns. Remember that water quality varies greatly, and the contaminants you need to address will differ based on your water source. Testing your water is the first crucial step before choosing a water filter. By understanding your water's makeup, you can target the right filtration technology for the job and ensure you're getting the cleanest, healthiest water for your home. If you want to learn how you can easily test your water quality at home, then you can click or tap right here to check out our video that explains all about it.